This is the ChronoAI Quantum Experiments results dashboard, the full data from our quantum context research series, updated through May 2026. What you're looking at here is the summary of 3 experiments run across 4 different backends, and I want to call out that cross-architecture validation note right away because it's the headline of this whole update. IonQ Forte 1 uses trapped ion qubits. IQM Garnet uses superconducting qubits. Those are 2 fundamentally different physical approaches to building a quantum computer, and both of them produce the same results across every experiment. The stats across the bottom tell the story fast. 4 backends, 3 experiments, 4 scenarios, confidence range of 83 to 97%. 2 of 4 scenarios changed outcome when you add entanglement, and 4 out of 4 control flip predictions hit on real hardware. We'll get to what all of that means. Experiment 1 is the context frame selector. The circuit encodes 2 business signals, revenue pressure and technical focus, and collapses to one of 4 operating modes. Scenarios 1, 2, and 4 behave exactly how you'd expect. High revenue pressure pushes towards strategic or technical build depending on what else is high. Low, everything lands on scrappy, clean, intuitive results. Scenario 3 is the one that doesn't behave. Low revenue, high technical, you'd expect deep technical build. Every backend selects active sales mode instead. IonQ at 94 to 96%, IQM Garnet at 92, AWS SV1 at 96, local simulator at 95 to 96. 4 completely different backends, same anomaly every time. That's not a hardware glitch. That's the circuit reading something real. And we're going to prove what it's reading in Experiment 3. Experiment 2 asks a direct question. Does the C0 gate actually matter, or is the circuit just doing classical probability with extra steps? The test is simple. Run every scenario twice, once with the C0 entanglement gate, once without it, just 2 independent qubits with no correlation between them. And both of these results held across IonQ, IQM Garnet, and AWS SV1. The entanglement layer is doing real work under high-pressure conditions. Now look at scenarios 3 and 4, the low-pressure cases. Scenario 3, low revenue and high technical. With C0, you get active sales mode. Without C0, you also get active sales mode. Converged. The gate made no difference. Scenario 4, both signals low, C0 or no C0, you land on scrappy no budget. Same result either way. This is the pattern that makes the experiment defensible. Entanglement changes outcomes specifically under high pressure and not under low pressure. That's not random. That's the circuit detecting something structural about the relationship between variables, and it only shows up when the stakes are high enough for that relationship to matter. Classical probability can replicate what you see in scenarios 3 and 4. It cannot replicate what you saw in scenarios 1 and 2. Experiment 3 is where we stop observing the anomaly and start explaining it. The hypothesis is this: if the scenario 3 anomaly exists because revenue holds the C0 control position, then flipping the control qubit from revenue to technical should move the anomaly. It should disappear from scenario 3 and appear somewhere else. Scenario 1 confirms the baseline. Original circuit gives you strategic big picture at 85%. Flip the control qubit and it shifts to deep technical build at 89. The frame moved with the control qubit exactly as predicted. Scenario 2 is where the anomaly migrates. Original circuit, deep technical build at 89%. That's the expected result. Nothing unusual. Flip the control qubit and it collapses to active sales mode at 89%. A new anomaly appearing in the exact scenario predicted at the exact confidence level predicted. This was run on IQM Garnet real hardware, not a simulation. Scenario 3 is the proof. This is where the original anomaly lived. Low revenue, high technical, selecting active sales mode at 91% when you'd expect deep technical build. Flip the control qubit and the anomaly is gone. The same inputs now select strategic big picture at 90%. Exactly as predicted. The anomaly didn't disappear because we fixed something. It disappeared because we moved the control position. It traveled with the qubit. Scenario 4 stays put. Both inputs are identical, so flipping the control doesn't change the geometry. Scrappy no budget at 97 and 95%, both directions. That's the control case showing the flip only matters when the inputs are asymmetric. 4 out of 4 predictions hit. The anomaly is a mechanical property of the circuit, not noise, not luck, not a simulator artifact. 6 findings from 3 experiments across 4 backends. 1. Entanglement changes outcomes under high pressure, not low. The C0 gate reads variable relationships, and under stress, those relationships override individual signals. 6 findings from 3 experiments across 4 backends. 1. Entanglement changes outcomes under high pressure, not low. The C0 gate reads variable relationships, and under stress, those relationships override individual signals. 2. The Scenario 3 anomaly is real and persistent. Low revenue plus high technicals selects active sales mode at 90 to 96% confidence across every backend we ran. The circuit is reading avoidance behavior, not technical focus. Classical threshold logic cannot produce that result. 3. The control flip confirmed the mechanism on real hardware. 4 out of 4 predictions hit. The anomaly travels with the C0 control position. That is a mechanical explanation, not a statistical one. 4. Cross-architecture validation. IonQ4Day1 and IQM Garnet are built on different physics. Both produce the same pattern. The result is architecture independent. 5. Hardware and simulator are consistent throughout. Results differ by 2 to 8% across backends. These are not simulation artifacts. 6. Classical replication is insufficient under high pressure. The entanglement layer produces qualitatively different context selection exactly when it matters most, when the signals are high and the decision is non-obvious. That's the full dataset. 3 experiments, 4 backends, 1 consistent answer.